this is clearly to be edited out.
Nice. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
Totally unrelated. This is episode 210. This week we'll be talking Living in the Future, Flipper Mayhem, and Samsung moons the world. This week in the news, we've got, first of all, welcome to the show, Al.
Oh, thanks, Elliot. I appreciate it.
Al is a longtime Hackaday writer. How long have you been writing for Hackaday?
I always forget the year, but I've up to about 3,100, I think, posts. So that's a pretty good indicator. It's been a long time. And always enjoy my association with Hackaday. It's just so cool to see all the stuff that people are doing and to be able to point out some of the fun stuff and maybe even put a little original content out that might help somebody. So It's a cool gig.
Yeah, your Linux Foo column is super popular, super well read, and super helpful. I know I've learned things from it, and I use them in my daily life.
Well, I'll send you an invoice.
I think you have. I think we paid that out already. I think we're good.
You're right.
Other Hackaday-related news, the Low Power Challenge is coming to an end on Tuesday the 21st. So if you've got any low-power projects, whether that be like solar, power harvesting, just anything that can squeeze the last few milliamps, microamps out of a battery, let us know. Head on over to Hackaday.io or, I don't know, just type in Low Power Challenge into the search bar at Hackaday.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? Have you ever done the What's That Sound challenge before, Al?
I have not, although I did take the liberty of listening to it on the share there.
All right, good. Well, last week was a sound challenge week, and this week we get to pick the winners. But before then, I like to try to stump my co-hosts. So have a listen to it and tell me what you think.
I was assuming that was the audio track off the video of you getting married and trailing tin cans behind your car with just married painted all over it.
A lot of people guessed that. Would you believe this was a background noise when Tom and I were recording a couple weeks ago? This is actually recorded from Tom's house.
Wow.
What do you think?
Was there a wedding going by outside the window, maybe? I don't know. I may still be right.
You might be. And not crazy. A lot of people guessed similar things, including portable cement mixer, a sink garbage disposal, water droplets on a metal sheet. That'd be a cool one. Something caught in the fan blades, compressors, metallic surfaces, rattly AC units, metal fan, popcorn popping. We got so many wrong answers on this one, and only two correct answers. Both of them were a radiator.
Like a car radiator or like in a flat?
I suppose you don't have radiators in Texas.
We have radiators in our car, but yeah, that's what I mean. Or is it like the old radiator steam heat in the building radiator?
This is like a hot water radiator, heat your house radiator. So I actually had to look this up, why they make noise. Some people say it's air bubbles. Some people say it's crud in the pipes, but it definitely makes that noise.
Yeah, it sounded tinkly to me, so I wouldn't have guessed that.
It's weird, too, because it comes and goes, and I think also because Tom lives with it, he just doesn't even hear it anymore. So, like, I heard it in the background. I'm like, what is that? And he's like, what? Nothing. And then we listened to it for a while, and I'm like, is that your radiator? And he turns around, and of course it is. So there you go. Anyway, two correct answers. One from Steve++, and the other from Jörnild. It's that O with the slash through it. I have no idea how to pronounce that. Two correct answers. We'll go with Steve++ is heads and Tjornild is tails. I'm flipping a coin. We'll see what we get. Tails it is. Congratulations. I have to say it again to Tjornild. I'll send you an email shortly. We'll get you a Hackaday podcast t-shirt on the quick.
So, Elliot, shouldn't you be flipping a pseudo-random number generator on an Arduino?
I do that sometimes. I actually wrote a script that takes a picture with my webcam and hashes it and uses the hash of that to do it. I I've done a white noise generator. I love random number generators, actually. One time I did a decade counter and just let it run and then pulled the wires loose and saw what number it came up with. This was actually a Canadian $2 coin.
Huh?
It says knowledge on it and has a picture of some polar bears or something on the back. Kind of cool.
Well done.
All right, and that brings us to the hacks. I'd like to start off with a controversial post. AI and savvy marketing create dubious moon photos. This was a Reddit post, and so iBreak was testing the Samsung smartphone. I think this one was an S20 Ultra, but it may be with all of the modern ones. And Samsung had a popular ad campaign where they, touted the quality of the camera by taking photos of the moon. And in this Reddit post, he does a bunch of experiments that make it very obvious, I think. I think it's basically a slam dunk that they are doing some kind of AI upscaling on pictures of the moon in particular, and apparently also some other objects, where they have an AI trained on it that then adds to the resolution. And like one of the tests he does is takes 170 by 170 pixel image, blurs that out, puts it up on a monitor, and takes a picture of it. And the phone comes up with a higher resolution picture of the moon than he even gave it as source material. That alone, I think, is pretty much a slam dunk. What's really interesting is he then does this other test where he has a whole picture of the moon and then a half picture of the moon. And they have identical resolution. They're taken on the same monitor in the same shot. And the one that's the whole picture of the moon has fantastic detail. And the one that's just the half doesn't get image recognized as being the moon and is left at the original blurry state, which points out that there's like a two-step AI process going on here. First, it says, is this an image of the moon? And then it says, I've got an AI moon upscaling, learned algorithm that I'm going to apply to this. And then, to make it even worse, he takes the same picture of the moon and he puts a gray square on it and puts the same gray square off the picture of the moon. And of course, the gray square that's on the picture of the moon gets moon texture overlaid over it, and the other one doesn't. So, really, really slam dunk here. Some commenters point out that Samsung basically admits to this by saying that their scene optimizer, when the AI recognizes objects such as the moon, the detail enhancement engine function is applied to make photos clearer with multi-frame synthesis, which isn't cheating as far as I can tell. It's like taking multiple of your pictures and combining them together, and deep learning based AI technology. And yeah, who knows what that means, right? And so that, I think, is where the confusion lays. And if you read through the comments, a lot of people are trying to say that Samsung's camera is all that, and it's not just like cutting and pasting a picture of the moon over the top of it. But of course it's not. It's trained on 1 million moon images. It's just like making something as moon-like as it can.
Well, as always, this reminds me of Star Trek, right? Because it's the transporter problem. If Captain Kirk gets on the transporter pad and beams over, is it really still Captain Kirk that gets off the other transporter pad? Or did you just kill Captain Kirk and now there's a new guy, you can't tell who it is? So, it's sort of that, right? I took a picture of the moon, or did I? And if it's exactly the same as the moon, it's a little easier to resolve that for the moon picture than it is a person. But if it's the same picture of the same moon, maybe that's okay.
Yeah, someone said this in the comments. They're like, well, why don't you just replace it with someone else's picture of the moon? And I'm like, well, that's kind of almost what they're doing. I mean, they have a model that's trained on the moon, and they're like changing your pixels into those pixels. So they kind of are.
An old colleague of mine used to say he has quit taking pictures of anything that doesn't have someone he knows in it. Because, if you're, say, at the Eiffel Tower and you take a picture of it, well, you can go on the internet and find millions of great pictures of the Eiffel Tower, right? There's no reason to take a picture of the Eiffel Tower. So you could probably make the same argument for the moon is, there's the moon. Well, it's been there for a long time. It's going to be there for a lot longer. There's a lot of pictures already of it. Do you need to take another picture? That would be his attitude. So if it doesn't have, his kid or his wife or something like that in it, he doesn't take the picture.
Yeah, right? NASA has better pictures of the moon than we'll ever take. Just use those.
How did we not go with the title of Samsung Moons Everybody? I think that would have been... You'll probably cut that out, but that's okay.
Well, I might leave it in. Who knows? We've seen this before, and actually Samsung's getting lambasted here, but they're not the only one doing it. The iPhone camera also has an AI enhancement mode, and we've written up a great article. I'll throw the links in the show notes. Is the iPhone camera too smart or not smart enough? There are some extreme examples there, and one of the articles we linked to has some great demos of it interpreting. There's a motion blurred finger in front of a wine glass, and it sees the contour of the wine glass and draws it in front of the finger, even though physically it was behind it and stuff. And so there's some really eerie stuff you can push iPhone cameras into imagining. The funny thing is this was like just before the world got, DALL-E and Stable Diffusion and all the crazy dreaming, hallucinating image AIs unleashed on it. So it was weird to have a camera doing this back then. Now it's like, my camera sees the moon. Doesn't even freak me out anymore.
It's interesting that you could make the case that artificial intelligence, as it gets smarter, is going to be more susceptible to optical illusions, just like human intelligence. It's just maybe a different class of optical illusions, right?
Yeah. Oh, that's a good one. Before we leave, the last thing this made me think of was Sony's cameras, the A5000, A6000 series, has a skin smoothing mode that you can apply to video that looks, to my eyes, actually totally uncanny valley, but you could turn it off most of the time unless you're using the external HDMI out, which most serious videographers are using. And so because of this bug, I think, in the Sony firmware, videographers have to use skin smoothing mode all the time. And if you watch YouTube videos, you'll see lots and lots of people who are using it either on purpose or not. But it's not just like this plastic face uncanny valley problem, but if you move your hand in front of your face and it loses its facial recognition detection, it then takes the smoothing effect off. And so if you watch enough YouTube videos, you'll see videos where people get wrinkles on their forehead and then lose them, and then get them and then lose them, and then get them and then lose them. And that's a sure sign that they're shooting on a Sony A5000, A6000 series camera. If you want to hack around this, there's a fantastic hack, link in the show notes, from Sebastian, who's also the guy who did the Game Boy Interceptor. His workaround here is to slightly zoom in a little bit, and it uses this, quote, clear image zoom function. And this then overloads the camera's internal processor so much that it decides it can't do skin smoothing anymore. And so it just gives you the photo you actually were taking.
Photography through denial of service, right?
Confuse it, and maybe it'll actually take the picture right.
My first hack of the week was from Russ Maschemeyer. I hope I'm pronouncing that right. Immersive virtual reality from the humble webcam. And it was kind of interesting that he looked at an old video where they had the Wii remote. And you remember the Wii remote. Everybody was doing something with that. But it was kind of a weird setup. Usually you would see people making like whiteboards that you could draw on with your finger or whatever, and you'd have the little LED attached to your finger. This one, they had a sensor bar attached to your head, and the Wii remote was fixed, and they would do the eye tracking from that. So as you're looking at the monitor and you move your head, the scene would get adjusted to, look like you were looking through a window instead of looking through a flat monitor. So it seemed like such a great idea, and Russ was, kind of commented, well, but how come we haven't seen anything since then? Because that video was from, I think, 2007, I believe. And he decided to try to duplicate it and see what was going on. So he did a different take on it. But there were a couple of reasons he mentioned in the post about why it hadn't caught on. And part of it was like you have to know the exact physical dimensions of the window, not the pixels, but, the screen is 12.6 inches by, however many inches. And that was a problem, but there were some other problems, not the least of which is you have to walk around with a sensor bar on your head, right? That's obviously not ideal either. But I thought it was really creative, and I thought it was interesting too, because, we go a lot into the retro space here on Hackaday, And it's interesting how some of these old ideas, you can kind of say, wait, why, how could we do that again today? Maybe it'll be better now. I think in this case, maybe it wasn't really better, but it was still pretty cool. But I think sometimes you see things like that and you could come up with something a little better now with the current technology. So I don't know if that would have been a time of flight sensor. Maybe, I don't know if he's got plans to do any more with that, but I thought it was really a cool VR demo with some pretty easy to obtain hardware.
He calls it, Johnny Lee's mind-blowing Wii Remote hack. And yeah, I actually remember seeing that one when it was brand new. It's true. And actually, because it's not really doing 3D, it's not giving you the stereo two eyes separation effect, but it is giving you depth when you move back and forth, and you can see things that would be occluded by things that are in front of them and stuff. And so videos of it look just stunningly convincing.
Yeah, the Wii remotes were very cool. At the time, those were real popular. A friend of mine was actually had retired and become a high school teacher, and he would set his classes up in project teams, and they would do little projects, and they would have to, basically run them like a real professional project. And they would come to a breakfast group that I'm in and present. And one of them had done a whiteboard that normally costs the school, I don't know, $1,000 or, whatever overinflated price they're charging the school districts. And they had made it with a Wii remote and an infrared LED. And the presentation was just awesome. And they had done such a great job, and the craftsmanship, the workmanship. And I was thinking, I want to hire this kid, right? I mean, where do I sign this guy up? But of course, he was on his way to college. But it was a great example of where, even a student with some pretty good hardware and a little guidance could do a super project and actually save the school a bunch of money. They actually used the whiteboard afterwards.
All right. My next hack is Flipper Zero Mayhem hat adds camera and more radios. This is a project by Erwin Reed. The Flipper Zero is kind of an all-purpose radio hacking tool, except it's not quite all-purpose. When it came to the crowdfunding finish line, I guess they didn't have enough money to do a Wi-Fi and Bluetooth radio. So they have kind of low-frequency radio interfaces, but not a 2.4 gigahertz one. On the other hand, they left an expansion port on the back, and that's what the Mayhem hat / shield / whatever plugs into. And it's basically just an expansion board. It gets a lot of its power from being connected with software, in particular the ESP32 Marauder firmware. Plugs up to the ESP32 camera module that he's got on his breakout board and lets you do cool things with that. But you can also use an NRF24. You can also use some low-frequency radio chipsets like a CC1101. It's actually got a breakout, so you could put like arbitrary 3-pin sensors in there, so you can use like one of those temperature humidity sensors for whatever reason. I have no idea. But like the story with the Flipper is not that it's doing anything particularly unique or inaccessible. It's just wrapping it all up into such a nice form factor and with such a nice like GUI to navigate it, that it just makes it inviting to play with kind of low-frequency radio hacking. And this board then adds onto that a camera, a Wi-Fi, and so, have fun with the software on that. So far, there's like a Game Boy-esque camera attachment. There's all sorts of Wi-Fi messing around due to the ESP32 on board. It just looks like a great expansion board if you happen to have a Flipper. It's also worth noting that Erwin has these for sale on Tindy, but they're totally out of stock. Hopefully he'll get some more made pretty soon. Given the popularity of this device, I can totally see why his got sold out so quick, because if you're going to have a universal radio hacking tool, you gotta have 2.4 gigahertz on it.
Well, these are the ones that are being confiscated in Brazil, right? So maybe he can buy back the stock from the confiscated ones.
Yeah, right.
I don't know. Mayhem Hat always reminds me of a failed title by Dr. Seuss, but I do think that the Flipper itself is so interesting, because I've often thought that's where everything ought to go. And there's probably a reason it won't, for liability and legal and all sorts of other things. But think about your phone. Your phone's basically a computer and a digital signal processor. And the only reason it doesn't do more is probably because the software does what it needs to do, and that's it, right? But imagine if somebody like a Pine phone were to say, okay, here's your Linux box, here's an embedded processor for real-time stuff, and here's a DSP that can go from DC to light, basically, and some kind of tool set that makes that where mortal people can do things with it. So want a 2-meter handy talkie? Well, whip that up, right? Want a satellite duplex system? Perfect. Whip that up too, right? And it's all in your phone. That seems like that could happen, and probably the reasons it won't happen are not technical reasons, right? There should be a hacker phone, right? And it's got ports, and it's got ability to break out, and it's got a wideband DSP, software-defined radio, all that stuff built into it, and that you can get to. And like I say, legally, you'd never get that type accepted, and that's even in the U.S., God forbid, everywhere else. So I'm guessing that's not some product we're going to actually see anytime in the near future.
Yeah, but you just have to figure out how to do it yourself, and then you don't have to worry about it being
there.
A product.
You go.
The flipper kind of reminds me of like Arduino in a way. Like there was all of this radio hacking done before. It was just hard to do. And then you get something that comes along and makes it easy for everyone to do. And then all of a sudden, playing with garage doors becomes a popular, fun thing to do. Part of me, my elitist hacker part, looks at that and goes, ha, pish tosh. And then my popularist hacker part of me says, oh, that's awesome. It's bringing so many new people into playing around with this sort of thing. And just, the ability to read and broadcast at 433 megahertz brings you control over all sorts of these like household devices. And, it just opens a lot of doors. And so that part of it I really love. And it also reminds me of when the USB rubber duckies were coming out. And these are little, programmable USB device that then emulates keystrokes and starts typing on your computer to do cool or malicious things. At the time, I remember seeing this and going, there's nothing interesting there. You could write this code yourself on an AVR using any of the available USB libraries. But what this did was this gave it a nice scripting language and wrapped it up in a cute package that a whole bunch of people were working on. So everyone was contributing scripts. And it really kind of opened up the security community to how bad untrusted USB devices can be when you plug them into arbitrary computers. And I think that's actually a really useful side effect of making things like this that are kind of maybe a little arcane, making them accessible to everybody else. And so people can, just more people can start playing around with these ideas and trying them out. And I think that's what's awesome about Flipper too.
Well, you've got the elitist hacker and the populist hacker. How many personalities are you harboring in there, Elliot?
Touche. I got a lot of hats.
But, the folks making the Flipper, maybe that's a come on. It used to be that was a surefire way to get people to come to your play is say it was banned in Boston. So maybe they need to put on their Tindy page, banned in Brazil. Well, my next pick, not a big surprise, was A Love Letter to the Sphere Computer by Ben Z. I love the old computers. I was just the right age when the Altair 8800 came out in Popular Electronics to badly want one. And they might as well have been $1 million for me at that time. So I never actually had a real one. I've got a couple of fake ones now, but I used to look through the pages of Kilobaud, if anybody remembers Kilobaud, and Byte and PC Magazine and all those old great magazines and just drool over all this hardware. So I definitely remember the Sphere. It was kind of an offbeat computer for its day. 6800. It didn't have a card bus. It had a ribbon cable bus, which apparently wasn't a great idea. And now looking back at it, from however many decades ago that was. One of the things that was interesting is it's a little bit fuzzy on who first had the idea of, hey, what if we bundled a whole computer together and sold it as an appliance instead of saying, well, here's an Altair, but you also need to go get a teletype or a special terminal or something. No, it's just all put together. And so everybody kind of knew that needed to come about. People were building TV typewriters and, there was the VDM display board that you could put in an Altair. But having it all packaged up pretty much is either the Sphere or the Sol 20, which is something we talked about a couple of weeks earlier. And I think the Sphere might actually have been first, but it was kind of hampered by both being a 6800 and they didn't sell a whole lot of them. I think the Soul had a lot better distribution, and so there really wasn't a whole lot of the Sphere computers built. And I think, in fact, Robertson from MITS said something about, well, it's the best computer nobody's ever seen an actual one of. And I think there was rumors that they never actually made any at that time. But of course, obviously people have them. And in fact, Ben Z apparently found one and didn't know what it was. So I love these old computers, and it's amazing that you can still kind of make them work, and they're somewhat serviceable. You have to wonder how long that'll continue. If, in 100 years, will you still be able to get something like this to boot up, or are you going to have to be satisfied with simulations? The cost of it, too, is always so interesting to me. When you think about the adjusted value of money, the CPU board alone was $522 if you built it yourself. So this is in 1977. $522 was a lot of money in 1977. Not that it's not a lot of money now. If you wanted it built, that was $860. But if you wanted the whole thing, which was really kind of the point, right? It was the nice box with the monitor and the boards and everything in it. That would run you $2,250. Now keep in mind, that's with 20K of memory, a cassette player, and no floppy disks. Then you started getting into $8,000 if you actually wanted floppy disks. So imagine that's even more than $8,000 now by a large amount. Elliot, I don't know what you got sitting on your desk, but my computer now could emulate about 10,000 of these and not even break a sweat, right? Disk storage out the wazoo, multiple cores, high speed. So what a future we live in, that, this was a reasonable shot at the computer market in 1977. And here we are now with, for $1,000, you can buy more computer than most people need.
I do love seeing these old computers, and I didn't know about the Sol 20 until I read about it in Hackaday, and likewise, I didn't know about the Sphere. I guess I was just too young for those at the time, but not by much. I missed out. TRS-80 color computer was my first one.
Well, you never forget your first. I do love the old machines, and like I say, the Altair was particularly appealing, and I wound up building an 1802 computer back around that time because that was reasonable to do, and that was a lot of fun, but very inexpensive. And, in fact, some of my first articles I wrote were for Quest Data, which was a newsletter from the Quest company that made I think it was the Super Elf, or one of the Elf clones. And so, I did 3 or 4 articles in there in 1978 or 79, and that was really how I got started writing in the computer business.
Bringing up the rear, my last long hack this week comes from Nathan Farlow, breaking into the Nintendo DSi through the browser window. We were just talking about retro computing. This is like retro hacking. It's a 15-year-old device, and that means it kind of also has 2008 era security on it. And that makes it a joy to try to find the exploit hacking in it. And that's exactly what's going on here. It's got an old version of Opera browser in it. And so Nathan thinks to himself, that'll be easy. I'll find some documented bugs in old Opera 9.50 and I'll just exploit them and take care of it. Because it's that old, it won't do address space layout randomization. So, get an exploit and then he should be able to run stuff. Unfortunately, it doesn't end up being that easy. His chosen tool to attack the browser is to use a WebKit layout testing routine and then just kind of fuzz around that. That's actually a really cool method. He's emulating the device on a computer and then firing up a web server to send it kind of arbitrarily buggy, glitchy, odd web pages and seeing which of them break the Opera web browser. And a number of them do, but they don't end up being useful in that they don't have like a dangling pointer that then he can inject code onto the heap with. He stashes the project. I guess he's got to go to school, comes back to it again a year later with a new idea. And that is, if he's running it in emulation anyway and using Wine, he can actually set one of these debug flags to warn you when there is a use after free bug or something like that. And so he does that, and then he starts his fuzzing again, and he ends up finding a page fault where he can write some code in, and the rest is like hacking like it's the early 2000s again. He just puts a bunch of no operations in there and then his shell code at the end, and voila. So he's got an exploit on the slightly long in the tooth Nintendo DSi. I just thought that it was neat that he's hacking on an older device, and it means that he gets to use these techniques that would be simpler than doing it on a modern device. And so I like that as kind of a fun hacking time rather than serious brain numbing work.
Well, it kind of reminded me of like having an old project car, right? Because you get a car now and, you need $5,000 worth of equipment to even diagnose it and, set all the right parameters in the ECU and the special tool that takes this off. The old car, what'd you need? A socket set, a timing light, right? That's it. So that kind of reminded me of that. Maybe that's why, same way with repairing old radios. If you look in consumer electronics now, it's really hard to fix, but in the old days, grab a couple of tubes, take them to the drugstore, test them out, poke around with a big probe and a big soldering iron, and it was no problem. I did appreciate Matthew Carlson's analogy where he said, didn't stop people like Nathan Farlow from attempting to break into the old abandoned house through a rather unexpected place. The window. Well, the browser window, right? So,
yeah. Sweet.
So, kudos to Matthew.
Yeah, if you missed out on hacking in the early 2000s and want to see how these kind of use after free and dangling pointer vulnerabilities go, I'll throw you the Wikipedia link. It's a good starting place. Basically, the point here is that the compiler thinks it has deallocated some memory, but then it's left a pointer around to this block of memory that then gets called later. That's the use after free, right? It's freed up the memory, but yet it goes into that space anyway. And that's where the game goes. The idea is you figure out a way to get your data into that space, it runs it, and then boom, you take over. Cool old classic hack. Nice to see it in operation here.
My last one for the week is the Sign Labs USB protocol explained. And I got to tell you, when I first saw this, I thought, oh, great. Somebody else says, hey, look, I took a processor with a USB library and said, oh, look, it enumerated as a device. And I used it as a serial port. And everybody's done that and everybody can do that. And it's not really all that hard to do. But it turns out I was very impressed because he really did a nice, accessible explanation of how the low-level protocol works. So, if you know what a J-state and a K-state and a SOF and, all that, well, then you probably aren't going to get much out of this. But if you don't know all that, it really does go through at that level. And then, of course, at the end, he uses Lufa, which is an open source USB stack, and actually does kind of what I thought he was going to do at the beginning. But the exposition of the protocol was really well done, really accessible. And, I always say this, I've said it a million times, you don't have to know how a car works to drive a car, but you can bet at the Indy 500, every one of those drivers knows exactly how that car works. And I think it's the same thing here. As long as everything's going well, having your library that does your USB work for you is awesome. But when things don't go well, the difference in being able to fix it and not fix it is knowing this kind of stuff. It really was not the project as much as it was the data dump of how everything works. And I actually found myself wishing he would have gone a little further into some of the stuff like the ACM profile. And, there's pieces on top of the protocol, so it's a bunch of layers. And he kind of stops after the very low-level stuff. But hopefully maybe we'll see some more from him with the explanation of the higher layers, because I really like the way he did it.
Yeah, I love this one too. And I've actually looked into a lot of this stuff before, and, so I'm kind of familiar with it. And I've even played around with Lufa before, but it's really nice the way he presented it all. Like, this is like a full stack explainer from the beginning to the end. I agree with you that you don't have to know how to fix a car to drive a car, But it really is nice to know when you're implementing functions and if you have to build up like device descriptors or something. It is nice to know how they kind of fit into the whole USB ecosystem, because that lets you know why you're doing what you're doing, and it, gives you clues about how to do it. And when things don't work, you kind of know where to look. And at the very kind of most abstract end of the USB spec, you get like these HID device descriptors and stuff. And my God, the list of them is like 600 pages long and is really stunning. But the basic theory behind it is really just, you, the device, have to tell the host what kind of data it's expecting, and then the host says, okay, give me your data, and then you give it to it, and that kind of overview helps you understand why you're doing what you're doing, and that makes the coding a lot easier, even though you don't have to do all the super low-level stuff anymore.
A lot of USB coding I see these days is more or less cargo cult programming, right? So I took an example, and I think if I tweak this piece of it, it'll be what I want instead of the example.
Oh, I've done that.
You can get a long way with that, actually, but I think there's still a lot of area there where it's not always the right way to go. And it's funny, we build on abstractions. We all do, right? Almost none of us, if any of us, could go make silicon out of sand and polish it and crystals. And, we're all building on some sort of abstraction. But it does strike me that some abstractions are more mature than others. So, there was a time when you probably needed to know how to drive, say, an LCD display, character display. But now you probably just have a library that does that. And if all you want to do is show some stuff on the screen, you don't care anymore. It's well developed. It works well. It's very simple. So maybe we'll get to there one day with things like USB, but as of right now, it's still a pretty complicated dance, like you say, to get the enumeration right, get all the pieces and the endpoints that have to be registered and et cetera. So if you're cargo culting it, all that's just, go kill a chicken and look at its entrails. But if you understand what it means, you have a much better chance of making these abstractions work for you until they become a lot more sophisticated. I often say, there's two things that are simple, the very simple and the very complicated. So, if you want to float down the river on a log, that's easy. And if you've got a ship that you can push a button and say, take me to this port, and it does it with GPS and satellites, that's easy. But if you've got a 19th century sailing ship, that requires a lot of skill to operate, and you really do need to understand what you're doing. And I think that we're at the 19th century sailing ship level for some of this USB code.
My first quick hack this week is building the Sani cartridge reader to back up and restore games and saves. This is a project by Sani. It's a ROM dumper for all sorts of game cartridges, Sega and Nintendo. And I love these kind of hacks. This one, because it works across so many different platforms, has to worry about whether the cartridges are designed for 3.5 volts or 5 volts. And this project gets you into a lot of the detail about all the cartridges. If you happen to have these, and if you're one of those people who wants to play your retro games legally, this is exactly the device you need. Yesterday or a couple days ago was Pi Day, and Cristiano Monteiro built a Pi calculating Pi for Pi Day. And this is a RP2040 that is using a particularly efficient algorithm to calculate digits for pi. And he presses go, and it starts off, and I am surprised by how quickly it gets through. The first 20 just go whizzing by, and then it slows down and slows down and slows down for each additional digit after that. So he also included a 1 hertz heartbeat so that you could see it blinking as it comes up with the extra digits. I just love this because it's super minimal hardware. It's some 7-segment displays and an RP2040 in a box, but it does something really cool. Oh, and reading this project, I learned about algorithms to calculate the digits of pi. How many digits do you think of pi have been calculated?
Oh, it's an enormous number. A couple of million? I don't know.
Yeah, that's what I thought too. In 2000 something, the record was 2.6 trillion. And at least as of 2010, it stands at 5 trillion digits.
Wow.
What? And my last quick hack this week, solar-powered split wireless mechanical keyboard by Vincent Nguyen. This is a project over on IO. It's maybe the coolest keyboard I've ever seen. It breaks apart into two pieces, held together with magnets. Both sides are completely independent of each other and talk Bluetooth to a dongle. They both have a little screen on them for information, and they've got a strip of solar panels so that they can charge themselves back up and operate fully wirelessly. Everybody in the comments is going gaga. This is pretty much the crazy coolest keyboard I've seen in a while.
So my first quick hack was the Bluetooth calipers from U463. I don't know, why isn't everything Bluetooth connected? I don't know what else I can say about that, right? But my dream of the universal bus and just everything's there. The second one that I wanted to look at this week was from, I hope I'm pronouncing it, Nicolas Semino, and he's got a retro-style trainer for the Motorola MC14500. So I don't know why that processor just really fascinates me, and we've seen a couple of projects with it lately, but that's the 1-bit CPU. I recently noticed that the documentation for it was written by my old boss at Motorola, but I didn't have anything to do with it. So I guess that was before he had ascended. But, you know, it shows you how many little industrial controller things that need to be done that really don't have to be that complicated. And sure, you know, nowadays you just throw at the minimum an 8-bit processor into something because why not? They're literally pennies, especially at scale. And even the 32-bit processors are getting where they're not terribly expensive.
Right.
But you don't really need all that, just like we did plenty of stuff with the old Sphere or Altair or 1802 computers, even though they didn't have terabytes of storage and memory and, you know, gigahertz of clock speed. And then TRX Labs had a delightful post where he took a curve tracer from Heathkit, which of course obviously was old, and modified it to do MOSFET traces. And I just thought, what a great thing, rather than just have a piece of test equipment as a museum piece, to actually modify it respectfully into something that would still be useful on your bench. So I thought that was a good job and something I wanted to make sure everybody had seen this week.
That brings us to the can't miss articles. These are long form pieces written by our fantastic Haggaday writing staff. And this week I'm picking Joshua Vasquez's A Hacker's Introduction to DIY Light Guide Plates. And this is the story of his build of a Test Chamber 19 from Portal Sign. And of course in the video game it's eerily evenly illuminated, and he wants to recreate that effect and falls down the rabbit hole of trying to make an arbitrarily flat, evenly illuminated, large piece of acrylic, basically. And so he is firing a bunch of LEDs down the side of this panel, and the question is, how do you get the light out the front in the most uniform way possible? You've all seen those, like, LED light up acrylic things where you engrave something into it and that part reflects the light back out at you, right? So you could think of doing something like that. And he starts off with that and he thinks, you know, I could laser cut little pits in it. And if I do them all over the board, we'll see what happens. And so he does that uniformly and gets kind of the predictably bad result. And I'm glad he took a picture of it for us here. I mean, there's all sorts of other like reflector layers and diffuser layers in there to make it look better. But still, the fundamental problem is that most of the light goes out at the edges where it's closest to the LEDs, and there's just less light left over in the center to get reflected out at you. And so the solution is to make a pattern of dots that increases in density as it goes toward the center, or, you know, decreases in density as it goes out to the edges where the LEDs are and the spots are brighter. My favorite quote that comes out of this is, I was hoping to avoid writing some custom software to generate the panel pattern, but here we go. And he does. He writes a little spline that kind of gives you the density over distance from the edges, and then uses a laser cutter to cut this out. What was really nice about this write-up is that he looks into the way these kind of flat panels work in industry, in things like the LCD backlight illuminators and for monitors and stuff, and tries to consider all of the professional ways of doing it, and then kind of comes up with his hacker method of etching all these little holes by use of a laser cutter. But what I really like most is that this is one of those things that you couldn't have done easily before easy access to laser cutters and stuff like this. Like 15 years ago, if you had to drill all of these little holes yourself with like, just kind of dipping in with a drill press at each one of these little dots, you'd never be able to do this. But in terms of, just whip up a quick Python script and test it out on a laser cutter, problem solved. So it's really cool to, the kind of him working with the technology we got now and how that lets him get a really super professional looking result on a hacker budget.
Yeah, I was really impressed. Joshua is always, his mechanical skills and ability to just see things in the real world is amazing to me. And I don't have that. I often said, like, I can design a CPU and an FPGA allows me to realize that, but I could never mechanically make all the wire wrap connections like you did in the 60s and 70s. I would just mess something up, right? And I'd never figure it out. So to me, the 3D printers and the CNCs and the laser cutters, it's the same thing. I can visualize something, draw it out, and create it that I would never be able to, say, go into a regular shop with some hand tools and produce. And I'm talking about simple stuff, right? Things that normal people could easily do, I can't do. Given the level of sophistication that he has on mechanical stuff, this was super impressive. And it made me wonder if, like, these commercial things that you see, you'll see, if you go look on the sites where you're buying stuff from China, there's a million of these, right? I think he's got the one, Music is Freedom, or, you see 143 pandas, or the Starship Enterprise, or I think I got my dentist one that's a tooth one time, and the light shines up through it. It looks like a hologram. So do they have that same realization? Do they have the center has more, or is it just because there's so little light coming out that they don't have to do that? And I never really understood that. I don't know if this is something that they do commercially as well, or if it's something he kind of came up with just for this particular diffuse lighting everywhere kind of thing.
My guess is with a lot of the simple ones, it's just, wing it and, nobody will notice the light fall off. Unless you're trying to make it really flat like he is, it's hard to even notice. Yeah, if you're at all interested in this, he links an Agilent application brief at the bottom, light guide techniques using LED lamps. And if you've ever tried to launch from an LED into a sheet of acrylic, some of the problems you have are very, very well explained in this application brief. And then they also go around a lot of the other different techniques to get the light back out. Not just how to get the light in, but then also how to get the light back out. If you've ever taken apart one of these like cheap TFT LCD panels and then behind it, it's got this awesome illuminator. If you've got a busted one kicking around, you should really take one of those apart. They're really cool. They have this kind of, and I think Joshua has a graphic of this, they have this kind of sloping reflector and the LEDs shine at it and they shine up. And of course, because it slopes, you get some reflect off the front and some reflect off the back. And the really nice quality ones have not a linear slope, but a kind of a curve to them, I guess, so that they reflect proportionally more of the light that gets to them at the far end, but then it has an even illumination all the way across. Really cool stuff, and really neat job as a DIY implementation of that here. Super fun.
So my can't miss for this week is part of the series that Arya Voronova's been working on, and in particular this one is PCIe for Hackers, the diff pair prelude. It's really fascinating. It's looking at the PC board layout for differential for PCI-Express, but honestly, that's not really why I made it the pick of the week for me. It's the fact that this whole series has been so great at highlighting stuff that, and it's kind of what you were saying earlier, all this stuff would have been way beyond the hobbyist or hacker reach not that long ago, right? We didn't have access to impedance-controlled PC boards and layout software that could handle multi-layer, and, so much has changed so rapidly. Even using free tools now, you've got a workstation that would have been the envy of just about any engineer in a Fortune 100 company, not that long ago. So, it's very interesting, even if you don't ever think you're going to lay out a PCIe board, to see how all this works at that level. I think the bigger picture is if you look at all the work she's been doing on USB-C and PCI-Express, all these types of things that would have been just almost impossible to do not that long ago. And it makes you wonder, in 10 years, what are we going to be talking about? Well, in 10 years, we'll be talking about our surgeries, but what are people doing the podcast in 10 years going to be talking about that we would think are not feasible today, but will be pretty much within the reach of the hacker in 10 years?
Yeah, I agree. And her series on reusing laptop motherboards was really good. The USB-C series was awesome. I'm really enjoying these. There are 3 or 4 more, I think, in the pipeline on PCIe. She's done a lot of boards and breakout boards using PCIe and will be kind of giving us that experience. The other thing I really liked about this one, though, and it was kind of a new venture for her, was making a video of doing the actual layout and routing in KiCad 7 in this case here. And I know a number of people in the comments said, hey, it's really cool just to see you doing a practical layout in KiCad, because it's one thing to kind of read about how to do PCB layout. And, if you know what you're doing and if you've done a lot before, you could just read the how-to and get going. But if you're new to this whole thing and it seems a little bit intimidating, there's nothing like watching someone do a live video of like dragging out differential pairs and making sure that they're the same length and all of that, just so that you can see how approachable it is in the end. And I think that's really cool. And a really cool part of this particular post is that it's also kind of like a stealth mini KiCad walkthrough.
Yeah, and I think that's something we see a lot in comments, and maybe rightfully so. People will say, well, I saw that video and the guy wrote a blinking LED program on the Arduino. Why is that a video, right? Why wouldn't you put it out in text so that I could refer to it? But I think when you are operating some piece of CAD software like that, like KiCad or FreeCAD or any of those kind of programs, it really is useful to actually watch someone do it instead of saying, well, here's a screenshot of where I did this and see where the number 4 is. Well, that's the button you have to push. I think it is actually easier to watch the video for those sort of things. So, as usual, one size doesn't fit all. I will tell you the shocker picture in all of that, though. Did you see the picture for the wet string conundrum, where after explaining all the signal characteristics for PCIe, he says, well, in practice, you don't actually have to do that. And here's a picture of a board running off of, I don't know, what are those, probably 12-inch prototype wires. And it's just this rat's nest of wires. So apparently it's pretty robust. And, it's amazing. It's just like the Ethernet cables. There's all these standards which you probably aren't thinking about very often because they're commodities. But if you actually specify Ethernet cables, there's all this fixed and next and, but in reality, that can be a way off of spec and it's still probably okay for most uses, right?
I think she's going to get more into this later on, but PCIe, the protocol, does all of this stuff where it tries to make sure the data is getting through, and it does variable timing. So it changes the clock speed to make sure the data is getting through, and it changes data polarity to make sure the data is getting through. So are ones high or are ones low? It doesn't matter. Yeah. It's negotiated in the protocol. So there's all sorts of like horrible stuff you could get away with. But she also says, and I think it's probably the right approach to take, look, there's these standards. And if you get as close as you can to like what you're supposed to do, you can pretty much guarantee it's going to work. And if you want to do crazy, kooky stuff, you can't guarantee it's going to work, but it's so robust, you'll probably get away with it anyway. And so that really does, I think, take away a lot of the fear factor of doing super high speed, must be impedance and length matched traces. I think there have been a lot of demonstrations that it doesn't need to be as critical as you maybe think it does in the spec. And even the spec here is pretty mellow. I think with trace impedance, a bunch of people get talking about that in the comments, but I think the spec is something like, anything from 70 ohms to 100 ohms. Aim at 85, but don't sweat it if it's plus or minus 15 ohms on either side. And if that's the spec, in practice, you could probably get away with, 50 to 150. You didn't hear me say it. I am not saying this, but, the spec is pretty lenient on this. So,
Yeah.
Don't be afraid. Give it a try.
The problem you get into with hitting the edge on the specs is, corner cases, right? So let's say it's 70, but in the real world, when it gets cold and your components were off by 10%, and now it's really going to be 60. So is 60 okay?
Yeah.
Well, like you say, maybe it is, but you got to have a little margin. I don't know. I have mixed feelings because I'm a little frightened at how much stuff is like that now. So like when you boot your computer up now on a modern computer, it actually runs tests on your RAM to figure out how it can talk to it. And it's the same kind of thing, right? It goes through this training and it says, okay, I'll write some data. I'll get it back. That wasn't very good. Let me make some adjustments behind your back to let me try. Oh, now that works better. So, but it's actually impressive that it works as well as it does, that you don't really know it's doing it because it just works, right? I always think the king of that, you'd think the best engineering would be on a, safety bomb or a spaceship or something like that. But it turns out I'm always amazed at the ATM machine, right? The ATM machine always consistently gives you exactly the amount of money it's supposed to, or it knows that it can't, right? It'll say, oh, I don't have that much money. But you never say, I would like €100 and you get €90 or €110. You get €100 out of the machine every time, right? So I'm sure it's because if you mess up and your ATM machine puts out the wrong amount of money, they hang you or something, right? I'm sure it's some drastic reason that that's true. It's amazing that just works. It's something that everybody uses over and over and over again, and you just can't think of the last time it didn't work correctly. And it's kind of the same way with some of these really well done specs, is they just seem to work, and it's kind of frightening to think of all that going on behind your back, but it does work, so you can't really complain.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you would like to follow the links or enter in the discussion, head on over to the show notes, hackaday.com/podcast. If you see anything cool or do anything cool, write us an email, tips@hackaday.com. And until next week,
be sure to keep the hacks coming.
Cool.
Your own private Idaho?
Somehow Idaho is further away. Yeah, that's just right.
Okay, give me a second so I don't mute myself here.
What is the word I'm looking for? Where is it? Oh, I wrote it here. Right on.